right, so we're doing sequences today. Sequences are a little challenging. To find the next terms are okay, but to find the rules are a little challenging, okay? So we're going to try to chunk this and do one step at a time. All right, so you got a piece of paper with you, correct? You need to follow along with the video. And you need to take notes. All right, so you need to follow along as you are watching the video, and you need to take notes with that piece of paper. So make sure you're ready, because I'm not going back and rewinding. Do you understand? I'm not going back. So you need to make sure that you're following along. You may want to write on those squares with a pen instead of a pencil, because I didn't notice how dark they were going to be. I mean, you're only going to put one word on each one of them, but just in case you don't want to do it with a marker or with a pen, you can. You're only putting one word on each one of them. All right, are you ready? Okay, nobody's saying no, so I'm starting.
A sequence is a series of numbers that follow a fixed pattern, one after the other. The sequence can be either arithmetic or geometrical. Arithmetic sequences use the addition of a particular number. Geometric sequences use the multiplication of a particular number. For example, the series 3, 6, 9, 12 is arithmetic, because 3 plus 3 is 6, and 6 plus 3 is 9, and 9 plus 3 is 12, and so on. The series 3, 9, 27 being 1 is geometric, because 3 times 3 is 9, and 9 times 3 is 27, and 27 times 3 is 81, and so on. In the arithmetic, 3 was added to the previous number.
It's called a little bit of common sense.
Yeah.
Actually, one word in each one. Yeah, for those people that actually were paying attention and have a little bit of common sense, because I guess that's not true for everybody. The first two were supposed to be filled out with what? Sequences. So there are two kinds of sequences. One of them are arithmetic and the other ones are geometry. Okay. What math operation do you do in the arithmetic? Okay, so I guess that's where we will okay. And what math operation do you do on the geometry? Multiplication. That's it. You don't need to write any example. You don't need to write any of that. So you can move on to the next page. So what you should get from that first page is that there are two types of sequences we're looking to in arithmetic you add, in geometric you multiply. Okay, this is how I remember. Arithmetic has the letter A, which you add, and geometric has the letter M, which you multiply. Okay? Thank you, Effie. Thank you. This is why that team continues to win. All right.
Arithmetic addition, geometric multiplication. I have developed some basic rules to check for sequences.
Okay, so for the sequences, for arithmetic sequence, the first rule that you need to do to help you figure out how is it adding, you determine if the sequence is increasing or decreasing. If it's going up or if it's going down. That's the first rule. Determine if it's going up or down. Increasing or decreasing.
First, determine if the sequence is increasing or decreasing, going up or down. Secondly, find the difference between the first two.
The second one is to find the difference between the first two numbers. Okay, that's called the common difference because they all have it in common. All of them have it in common, that difference. Now, sometimes I've been doing it for so long that for me it's just a lot easier to figure out how much are you adding to it, so it's plus 3 or plus 5 or plus 10. Well, until you get used to them, I would definitely subtract because that's the opposite operation of addition. Very good. So you find the difference between the first two numbers. So you're going to do biggest one minus smallest one. Never do negative. Never do the smallest one. Plus these are the second number minus the first number. And then just to try it out, you do it with the third and the second. It has to be the same, okay? If it follows that pattern, then it's an arithmetic sequence. If it doesn't, it could be geometric or neither, okay?
The second and third number, the third and fourth number, and so on. If the difference is always the same, then it is an arithmetic sequence. Continuous.
So for example, if you do 18 minus 11, you get that that's 7. If you get 25 minus 18, you get that that's 7. And if you get 32 minus 25, you get that that's 7. So the common difference would be 7. Okay? The common difference is denominated by root. Okay?
Requires that the difference found is added or subtracted continuously. Now, to determine if the sequence is geometric, then
Alright, so to determine if the sequence is geometric, you need to figure out the multiplier or the factor. Which means, what are you multiplying? The first term to get the second term. What are you multiplying the second term to get the third, or the third to get the fourth? So if we subtract it and figure out what are you adding y, what do you think we need to do when it's just geometric? Okay, I'm going to say it again because people are not listening. To find the number that you are adding for the arithmetic sequence, you subtract it. Figure out the common difference. Thank you. So you need to divide that in. Sorry. Don't matter me because I didn't hear it. I was not ignoring you. So let's not take it personal. So you need to divide. Very good. So you need to divide because the opposite of multiplication would be division. And that is also called, it has a name. The other one was common difference. This one would be the common factor. Okay?
multiplier by which the sequence is increasing or decreasing must be identified first. If the sequence increases or decreases by the same factor, then it is a geometric sequence. Continuing the sequence requires that each number in the sequence be a product. Remember, a product is what you get from multiplying.
So this is another thing that you need to understand. That product is what you get when you multiply. That's why you have to divide to the opposite multiplication to figure out so you divide that number. gonna tell you something, when you're in high school next year, your teachers are gonna start bringing you books and tables without telling them exactly where to find it. And you learn how to do that. And this semester, you will, that you learn. They don't stop like I'm doing. They just teach. And if you're not there with them, good luck. That's your problem, not theirs. Okay? You need to learn how to take notes. You need to learn how to abbreviate things because nobody's going to stop a video for you to copy. All right? So I'm recording, so I would greatly appreciate the stupid comments to be omitted. Thank you.
Numbers. In this case, it is the last number times the factor by which the sequence is changing. For example, in 4, 9, 4. The sequence is...
So you take the old number, you multiply by the factor, and you should get the new one. That's also important. You take the old one, you multiply by the factor, and you get that new. And then that new, you're going to have to multiply it again by the same factor to get the second new, which will be the second number in your sequence. Okay? So your first number in the sequence was 5. The second number in the sequence was 30, and the third number in the sequence was 180. So you take the old, which is your first number, you multiply by your common factor, which is 6. That's your second number. That's your second number in the sequence. Then you multiply it again by the same factor, and then you get the third number in the sequence, okay? Now, when it's just numbers, it's pretty easy, but when we start writing rules, that's where it gets a little complicated.
changing. For example, in 4, 9, 14, the difference between the first and second number is 5. 9 minus 4 equals 5. Between second and third is also 5. 14 minus 9 equals 5.
So what do you think he's trying to do over here?
Find the margin figure. How much is going above the addition? How does it?
Find a common difference, which means he's trying to figure out if it's an arithmetic sequence or a geometric sequence. So you either use subtract, right? It's a what? But if you multiply, then it would be a. There you go.
With 4, the sequence is increasing by the same number, 5. And the sequence is arithmetic. The missing number is 19. 14 plus 5 equals 19. The next one, 24. Then 29. After 29, the next number is 34. 29 plus 5 equals 34. Then 39, and so on. Let's try another example. 4, 7, 11, 16. Here the differences begin with 3.
So what happens over here? The differences are not the same, so there's not a common difference, right? There's not a common difference. So what would you say about this sequence? There's neither. That might be okay. That might be correct. If you cannot find the difference, before you jump into neither, what would you do? There you go. Try to figure out if it's geometric. Okay? I always start with arithmetic because that's the easiest one, because you just add it, right? But then if it's not, if you cannot find a common difference, if you cannot find that number that you're adding all the time, then I will definitely go to geometric. If I can still not find it, then I will jump into neither. Okay? So always check if it's geometric first, and then go to your third option, which would be
minus
neither.
4 equals 3. Then 4, 11 minus 7 equals 4. 5, 16 minus 11 equals 5. Therefore, the missing number is found by adding 6 to 16 to get 22, and 7 to 22 to get 29, and so on. Because the number is not found by adding the same fixed amount, then the sequence is neither arithmetic nor geometric. One more example.
So it is not.
3, 9, 20.
It's not arithmetic or geometric if you cannot find that same number, but you can still find numbers in that sequence. Because because it was +2, +3, +4, +5, +6, +7. So it's not arithmetic or geometric, but that doesn't mean that I cannot ask you for the next term, because you can still figure out the next term, okay?
3 minus 1 is 2, and 9 minus 3 is 6. Okay, because the differences do not fit an addition pattern,
So look at this. They're different, right? So it's definitely not arithmetic, right? But then what do you notice between 2, 6, and 18? So if you say 2 times 3, you get 6. If you get 6 times 3, you get 18. And if you get 18 times 3, right, then that should give you the next number or the next difference, right?
differences are 2, 6, 18. The sequence is not arithmetic. However, the numbers do increase by a factor of 3.
So see,
Because
if it's
1
not
times 3
arithmetic, make
equals
sure
3.
that you check that
And
it's
3
arithmetic.
times 3
And
equals
this
9.
one is.
And 9 times 3 equals 27. Therefore, the missing number is 27 times 3 equals 81. And the next one, 81 times 3 is 243. So, the sequence is geometric.
All right, so if you go back,
Times 3 equals 9. 3 minus 1 is 2.
and you can find a pattern from those differences, there's a big chance that it's going to be geometric, okay? So again, times 3 times 3. And what was the pattern? It was times 3 all the time. So if you cannot find one that's arithmetic because you're not adding the same number, then try to figure out this. Or this one is just basically a lot easier to say 1 times 3, 3. 3 times 3, 9. 9 times 3, 27. And if you do the common multiplier by dividing, 3 divided by 1 is 3, 9 divided by 3 is 3, 27 divided by 9 is 3. So you multiply by 3 all the time. All right. So let's stop and let's do identifying sequences first, because I don't want to go into the formulas, because not yet, because that's a little bit more complicated. All right, so all we're doing over here is identifying if it's arithmetic or geometric. That's all we're doing. We're going to get a little bit of practice in this before we go to the actual formulas, because that's a little bit more complicated, right? So most definitely get your calculators out, because it's a lot easier to do with a calculator than it is to do with anything else. And let's figure out if it's arithmetic, number one, or if it's geometry. So to figure out if it's arithmetic, you gotta do what? You gotta find a common difference. You gotta find B. B is the common difference. Because you passed out the originals. I need the originals. The originals are posted. There should be somebody else that has. There should be somebody else that do. Thank you. Alright, so how do we find a common difference? Negative 18 minus negative 3. What's negative 18 minus negative 3? Okay. And then you say negative 100 and we found that difference. Now we need to find this difference right here. It's not the same, which obviously is not, because there's no way that negative 108 minus negative 18 will give me negative 15. Doing the calculator, you don't believe me. That's a big number. So then if it's not arithmetic, what's the number? Negative 90. It's definitely not arithmetic, right? Because you have different differences. If that makes any sense. Not factors. Differences. Then you gotta make sure that it's not geometric to figure out if it's neither. Okay? So it's not arithmetic. So how do we figure out if it's geometric? What do you gotta do? You gotta divide. So you're gonna say negative 18 divided by, so negative 18 divided by negative 3, that would be 6. Then I'm gonna do it with the second one as well. Negative 108 divided by negative 18. It's positive 6. So now I'm going to stop and I'm going to say, just to make sure I don't want to divide anymore, I'm going to say negative 108 times 6. Negative 108 times 6. Does that give me negative 648? Okay, multiply that again by 6. Should give you 3,000, negative 3,888. So what kind of sequences is this one? Okay, if you know guys know how to run 2 words, I'm just going to write it. All right, let's go to number 2. All right, so let's find the difference first. 4 minus 2? That will be 2. What is 12 minus 4? That's definitely not. 12 minus 4 is not 3. 12 minus 4 is 8. That's definitely not arithmetic, right? All right. So let's do the division. 4 divided by 2? So 4 divided by 2 is 2, but 12 divided by 4 is 3. So this is what? Neither. Let's go to number 3. $165 minus 35 minus negative 35. How much? 200. So we figure out the difference. Between those two. What about 365 minus 165? I think it's 200 as well. So I'm going to stop. I think that my common difference is 200, right? So what I'm going to do is I'm going to take 365 and add 200. I believe that's 565. And 565 plus 200, that's 765. So this is what? Okay, and then let's start writing the common differences or the common factor. What was the common factor over here? That was 6. It has a letter, but I can't remember it. I'm not sure if it's R. I don't remember. Okay, so I'm not going to write anything. I know that this one is D. If that was 200, I know that the common difference would be 200, and that's the number by letter B. I can't believe I don't remember. All right, number 4. So let's find the difference first. Do it with a calculator and you won't get, that's the problem. You're so lazy you don't want to do it with a calculator. So 6 minus negative 2, that will be 8. So we found the difference between the first 2. But now I got to find the difference between third and 2. So negative 18 minus? What is that? So it's definitely not arithmetic. Okay. So let's divide. 6 divided by negative 2? Negative 18 divided by 6? Alright, so it seems to be negative 3, right? Yes. So do negative 18 times 3 to get that 54. See if you get that.
Yes.
Yes. So which means that my common factor would be
-3.
-3. So this would be what?
Geometric.
Geometric. There you go. You're getting the drift. Alright. No, it's not D because it's not a color difference. D is for difference, right? I don't know what the answer for the, I think it's R, but I'm not sure. I'm not sure what it is, so I'm not gonna. Be quiet, please. Alright. Now, just by looking at it, you should know. You have a little bit of common sense. You should know which one you should try first. When the numbers are close together, it should be arithmetic. When the numbers are really further apart, it should be either geometric or either. Okay? And this is what I'm saying. There's no way that by adding, although that was 200, that was a big number too, right? 93, so sometimes I want to go straight to multiplication and sometimes I want to go straight to adding or subtracting. It depends on the numbers, but it can trick you, so you may want to just go ahead and keep trying the arithmetic first and then try the geometric. So that would be 93 minus -7. I believe that's 100.
Yes.
And then 193 minus 93 is definitely 100. So now that I've gotten two 100s, now I go to 193 plus 100. Is that 293? Yes. 293 plus 100. Yes. So this is arithmetic, and my mean would equal 1. The next one is really easy. Arithmetic or geometric? It's definitely arithmetic. If you have a lot of number sense, this is really easy to do. Number sense, not common sense. Number sense.
Which common
And then what's my common difference? What's my D? 6. Very good. You say 8 plus 6, 14. 14 plus 6, 20. 20 plus 6, 26, and so on. Right? All right. What about the next one? You don't know, let's try it out. -2 minus -1. That's -1. -6 minus -2, that's -4, so it's not arithmetic. Alright? Let's see if it's geometric. So the geometric, I'm going to take the second term and divide it by the first one. -2 divided by -1 is 2. -6 divided by -2 is 3. So it's not arithmetic and it's not geometric, so this would be neither. Alright, let's do the next one. It's arithmetic, most definitely. What's your D? Awesome. It's arithmetic and you're adding 6. -18 plus 6 is -12. -12 plus 6 is -6. -6 plus 6 is 0. And 0 plus 6 is 6. Very good. This one is really easy as well. Number 9. It's geometric. Thank you very much. Times what? Times 2. That's what you're doing. You're multiplying by 2. Very good. -2.5 times 2 is -5. -5 times 2 is -10. -10 times 2 is -20. What about that last one? Alright, so let's prove it. 2 minus 1 is 1, but 6 minus 2 is 4. So definitely not arithmetic, right? 2 divided by 1 is 2, but 6 divided by 2 is 3. So this is not geometric as well. There you go. Thank you. And that's the first thing we should have done and not do all this work. Nobody noticed. Except for my girl over there. right, find the next three terms in each sequence. First of all, you need to figure out what kind of sequence it is. Then you need to find the next three terms. Now remember, you can still find the sequence even though it is not arithmetic or geometric. You can still find sequence. You can still find terms. Alright. So 4 minus 2, 12 minus 4. So it's not arithmetic, right? So it's neither. So we still got to figure out what is the pattern. Okay? You do that. I'm not doing it for you. So you gotta, if you have numbers, then it's the easiest thing ever. There you go. Say it again, Sabrina. Times 2, times 3, times 4, times 5, which means the next number should be times 6. So 240 times 6.
1,400. Give me digits. 1, 4, 0.
All right, the next number should be times 7.
1,080.
10080. And then the next number should be times 8.
8,004.
800.
8,006.
Okay, maybe if one person can do it, because there's no way that my old ears can listen to 5 or 6 children at the same time. Yvette? 80640. All right, that's right. All right. Let's go to the next one. 5 minus 2 is 3, but 10 minus 5 is not arithmetic. 5 divided by 2 is 2.5. All right, it's neither, but we still need to find the next three terms. There you go. Plus 3, plus 5, plus 7, plus 9, which means the next one is plus 11, the next one is plus 13, the next one is plus 15. You got the drift? Alright, so 26 plus 11 would be 38? 37? 37, 47, 51? 50? Oh my god, I can't. And that's 65, right? I can't add today. Not put me on the couch because I have to. Alright, let's do 2 more before we go to the right hand circles, okay? 9 minus 1 is a 25 minus 9 is 16. So it's not arithmetic, right? 9 divided by 1 is 9, and 25 divided by 9. It's definitely not going to be 9, right? Okay, so it's not geometric, correct? So in here I added how many? 9. I added 8. Thank you very much. What about the next one? I added 16. Thank you very much. And the next one should be what? So 25 plus 24 is 49? Double check. So I should add how many on the next one? 32. Double check. 49 plus 32 is that 81. We just got to hear enough to go to that calculator and do it. So the next one should be plus what? Plus 40. 121. Plus 40. It's the timetable of 8, right? So how much is it? 100 what? 169. And then the next number that I need to add? How much? Yeah, but what's the number that I need to add? 56? 56, and that is 225? 225? All right. So can still find terms even if it's not arithmetic or geometry. Okay, you just gotta, so they're just a little harder to find. Okay. Which one are square roots? Those ones so those perfect squares. Good job. Very good. So you can actually take that first 7 square it. So then that would be 3, that would be 5, that would be 7, that would be 9. So not all the perfect square roots, but the odds perfect square roots, right? 1 square, 3 square, 5 square, 7 square, 9 square. See, and this is where figuring that out will help you. Okay? Because you didn't notice, but you just came out. Very good. You did not notice, but you just came out. All right. 4 16. So 16 minus 4 would be 12. What about 36 minus 16? So it's not arithmetic, right? 16 divided by 4 is 4. 36 divided by 16, I don't think it's 4. Alright, so it's not geometry. So let's figure out what we're doing. It would really be great for you to pay attention and actually try it. Some of you don't get it. That come January, you might be out of here. I guess you don't want to be here. What is it? So plus 12? Plus 20. So you're adding 8 all the time to that number that you're actually adding? Alright, very good. So that would be plus 28, plus 36. So the next one would be what? Add 8 more to 36. So plus 44. So which means 144. Now add 8 to that 44. That will be 52. Okay, now add that 52 to 144. 196. You have a calculator, so this should be pretty easy to do. Now add 8 to that 52. That will be 60. We need one more term. And then 256? All right, we got it. It's not that hard. You just got to have a little bit of number sense. Are we good? Okay. Those are perfect squares for what? Oh my God, give your family 20 points. That's awesome. Those are perfect squares. So this ones were perfect squares of odd numbers. This one's are perfect squares of even, positive even numbers, right? Square root of 4 is 2. Square root of 16 is 4. Square root of 36 is 6. So this is 2 squared, 4 squared, 6 squared, 8 squared, 10 squared, 12 squared, right? Good job. Very good. All right, are we ready? The next video. Uh-oh. All right. All right. Next page on your notes.
In this video, I'm going to show you how to create a formula for a given sequence. So suppose we got this sequence. So we give it a 7, then it goes to 10, then it goes to 13, then it goes to 16.
All right, fill it out. What should be the next one? Thank you so much for having me initially to do it. Are we good? What are the next two terms? 19 and 22. Okay, is it arithmetic or is it geometric or is it neither? It's arithmetic. What is your common difference? It's a 3. That means that it's always changing by what? By 3. Okay.
And then we've got a couple of blanks, and so it's growing in a very organized, predictable way. And so notice we already know what a 100th term would be. So 7 is the first term, 10 is the second term, third term, fourth term. So we can see that.
Now, why we're going to create formulas? Why do you think we need to create formulas?
So that we can find out what it is.
Yeah, exactly. Do you really want to create a list that has 100 terms? Heck no. Okay? So what you need to do is figure out how you're changing from that first term to the second, to the third, to the fourth, and to the fifth. So there's a pattern. If there's a pattern, there should be a formula that will be attached to this sequence that will help you just plug in what term is it and then get your number for the sequence. Okay? That's the purpose.
16 plus 3, which is 19. You can see that the sixth term is 19 plus 3 is 22. And we can keep going like this, and we can go up all the way to the 100th term. That's how we can get it. But boy, it sure be nice if we could come up with a formula that would give us the answer in a much quicker way. So that's what this video is about. So what you're going to do is we're going to take this sequence and let's put it into a nice table. So we're going to call this term.
Write it out.
1, 2, 3, 4, 5. And by then, we're going to see the pattern. We're going to be able to write the formula. And then
So he writes 5 because he has 1, 2, 3, 4, 5. Actually, he should have written a 6th one because he has 22, right? But that's okay. You don't need that many to come up with a term. So this is term 1, which should be paired up with what? 7. Term 2 should be paired up with 10. Term 3 should be paired up with 13 and so on. Okay? So the first term is the first number that you see. It's always called A1 because it's your first term. Okay? Then the second term is called A2 because that's your second term and so on. Okay? Now, arithmetics are really easy to come up with the equations or the formulas.
So what I mean by this is the first term is 7, the second term is 10, third term is 13, and 16, and 19. Okay, and then you want to go up to, let's say, the nth term is our formula. That's the formula we want. So the idea is in arithmetic sequence, it's called arithmetic sequence because we keep adding.
So you want the nth term because what if I'm asking for the 100? What if I ask you for the 84 instead of the 100? So that n takes the place of whatever term I'm asking you about. Okay? So you always call that nth term. And you're going to see those n's in those formulas, okay?
By 3 each time, adding by 30, add by 30, and add by 3. And if you think about it, what's a faster way of adding by 3 repeatedly?
Thank you. So that is a change, right? It's changing by 3 all the time, correct? So what's another word for change? What's another word for change? Thank you. Who said it? Slope. So the slope of this formula is what? It's 3 because it's changing by 3 every time. It's changing by 3 every time. And the definition of slope is the constant change. And this is changing by 3 every time. Okay? So that's slope. So what we're doing is we're learning how to create formula with things that we already know. Everybody here knows what a slope is. And everybody should know that the change is the same thing as the slope.
Okay, so we're going to go up to the 100th term, and so we're going to have to keep adding that 3, add 3, add 3, add 3. So what's a faster way of adding a bunch of
And
3?
Kevin just said this. He said multiplication.
by 3. So the formula is going to begin with n times 3. Is it n times 3 is because we keep repeatedly adding 3's.
Now, I would not write it, Miss Marie would not write it n times 3. What would you write? Which would be 3, and then okay? So that takes your place of your slope. The n would be your x, right?
So faster way to add it is by multiplying. Okay? So now here's the formula, the start of it, n times 3. So we look over here, and we say, well, let's try 1. So we got 1 times 3 times 3. But we didn't want 3, we wanted 7. Let's try it on 2. So we're going to do 2 times 3, because the formula is right here, 2 times 3, and 2 times 3 is 6.
All right.
But we didn't want 6, we wanted 10. And by now we should see the pattern, that if you get,
All right. So if I multiply 1, which is my turn, that's my n, times 3, I get 3, which is not 7, correct? So obviously I'm going to have to do something else to that number. Say that again? Add 4. So 3 plus 4 equals 7. So let's see, n times 3 would be 2 times 3, which is 6. It's 6 plus 4, 10. So what is that plus 4? Your y-intercept. So what? It only works for arithmetic. What is an easier way to find the rule of this? Thank you. It only works for arithmetic, not for geometric. It only works for arithmetic. You said it. You? Jackson? Okay, so 20 and 20. All right, so for arithmetic, you can now you already arithmetic. You can go ahead and go to stat and find that rule and replace that x by what? By what? The number of turns, which would be what in here? Yes, but what letter? N. Okay, N. So go to your stat, do this regression of the line, make sure that you get 3x plus 4. Let's go. Go to your stat. So you have the new stat to make sure that's correct. Okay. Did you get 3x plus 4? Yes. Yes. Yeah, I should go dropping. All right, did everybody get 3x plus 4? All right, but instead of that x, you're going to put that term. So finding it 100 term. Finding the 100 term. Write down the formula. 300 and? All right, so that was 100 times 3. That's 300 plus 4. So I expect you to have that formula. What's the formula? 3n plus 4. Start writing. And write your 100 term. Which would be 304. Thank you very much. All right, do the next one on your own. Go. Do the next one on your own. If it's arithmetic, then it's really easy to find the formula. Just go to stat. You guys already know how to do your stat and do your thing. It only works for arithmetic. It does not work for geometric. The other video will take us to the geometric. About the next two terms. So what's your comment now? 7. So it would be 7. So 17 plus 7, 24, and then 24 plus 7, 31. All right. So now all I need to do is create an x and a y table. Okay? You can do it going down, or you can do it going sideways. It really does not matter. Okay? Now, x would be your term, right? And then 100 will be the number on your sequence. The y will be the number on your sequence, which means the term determines the number in the sequence. So this is the independent, that's the dependent. Okay, so term 1 would be 3, term 2 would be 10, term 3 would be 17, and in reality, you don't need more than 2 to come up with a question or not, right? In the first 2, you know that your slope is what? 7, because it changes only on 7. So in the first 2, you don't need to write more than 2 points to go to stack. So when you go to stack, what do you get that the formula is? 7, but not x, and minus 4. Okay, so let's do the 100 term. So the 100 term would be 7 times 100, and then which is 700, take away 4, so 696. So that was 7 times 100 minus 4. Are we good? So when it's arithmetic, it's really easy to find the root. You just go to stack because we're going to equation number 1. Have a slope and has a y. Okay? Now when it's geometric, it's a little harder. So let's go to that one.
So you want to talk about geometric sequences.
You may want to write the formula down.
You may have seen this formula. A sub n equals a1 times r to the n minus 1, where a sub 1 represents the first term and r represents the common ratio. So I'm going to do a couple of problems. We're going to look at a specific sequence, geometric sequence, 3, 6, 12, 24, 48. I want to derive this formula just to show you where it comes from. Where a sub 1 represents the first term and r represents the common ratio. So I'm going to do a couple of problems. We're going to look at a.
No, you guys don't write fast enough because we've had this problem all year long.
You may have seen this formula. A sub n equals a1 times.
Hey, President, would bring your
n minus 1.
Okay.
It's an 8.
It looks like a 9. He said A. We're obviously not listening. He said A, then. What is the dot thing? It's a 1. No, you guys don't listen.
Where a sub 1 represents the first term.
A sub 1.
So I'm going to do a couple of problems.
So R is the common ratio, or the common most factor, okay?
I want to derive this formula just to show you where it comes from, just to give you some intuition. We'll use it to.
All right. So you have that sequence over there. It's obviously a geometric sequence, right? You have the 3, you have the, you don't have it? No? 3, 6? No? Next? All right, fill out the next 2. 3, 6, 12, and 24. So 24, the next one will be 48. It's over here. What's the common, what do they call it in the factor? What do they call it? The common ratio. Common ratio. And the next you have to figure it out what the ratio is you're dividing. And a ratio is something divided out. Something divided by something else. Ratio. So common ratio. All right, so we're going to derive the A sub n formula. So we're going to come up with a formula for this. Then we're going to find A sub 10. That means we're going to find the 10th term, because that's A1, that's A2, that's A3, that's A4, and that's A5. Now, A10 is really not that hard to do. You might be able to just go ahead and say times that, times that, times that 5 more times, right? But if I ask you A of 100, then no, who the heck wants to do times whatever all the way to 100, okay? So, and then we're going to say if A of A sub 2 equals 32. That's another one. Then A sub 5 equals negative 4. We got to find A sub n, okay? So it's not that hard to do, but it takes a little bit more math than the other one because the arithmetic, you just go to stack, do the line regression, and you're good to go, right? Because it changes the same amount, that's your slope, and it has a line regression. It could be 0 or another, okay?
Finder's notes. And yes, I know you can expand this out easy, but obviously the idea is you can easily find what had the first term using the formula without expanding it out. Then in a different video, I'm going to assume that we know a couple of values of the geometric sequence.
All right, let's go ahead and stop because I really want to do the F ticket. So we'll finish this tomorrow. Keep those two papers. I'll tell you tomorrow where to glue them. You can keep them in your folder if you want to. Just I don't want any papers on top of anything. Everything needs to be either inside your notebook or inside your folder. Okay? So if whatever family doesn't do that, I'm taking points off. I'm telling you right now, I don't want any papers coming out of notebooks. I don't want any papers coming out of folders. All right. Exit tickets, the answer sheets, we need to pass them out. You got them? All right. One person over here needs to look at the exit tickets. Another person needs to pass out the homework. Thank you.